Hi guys, and welcome to another ESP32 technical tutorial. In this one we're going to talk about linking your ESP32 to an open source graphics library called U8g2. U8g2. Not quite sure why it's called that, but it's an interesting enough name. Now U8g2 exists in GitHub. There's the URL up here, and when one downloads this, one can compile it as a component for your ESP32 ESP-IDF applications. So let's now talk about what is U8g2. When we think about graphics displays, specifically monochrome graphics displays, there are a variety of those in the marketplace. They're all pretty darn cheap, a few dollars each, and there are many of them. Now, depending upon the vendor of the particular graphics device, whether it be OLED or LCD or whatever, each one of those vendors has different communications technologies, SPI, I2C, various other technologies. They also have different commands that need to be sent to the display. For example, the command to clear the screen on one device is different from the command to clear the screen on another device, and the bitmap layouts of which pixels are where also vary depending on vendors. Is byte 0 the bottom left of the display, the top left of the display? If I send in 8 bits of data, is that going from top to bottom or left to right? And the answer is, it all varies. It varies depending on the vendor of the graphics display device. What U8g2 does is it normalizes that away from us. It provides an abstraction layer where we can think about the graphics actions we wish to perform, such as drawing circles, drawing boxes, drawing bitmaps, drawing triangles, drawing lines, printing text, drawing strings to the screen, drawing pixels, etc. So U8g2 provides an API where we can, in our C code, make these API calls to achieve a logical effect, and then U8g2 handles the interaction with the backend device. So specifically, the devices which are known to U8g2 include this list. So the list goes on, and if you're using a monochrome or OLED graphics display, chances are very high that that display will be found in this list. Certainly all the ones I have were found here. So this is a quite comprehensive list of the different devices supported by the U8g2 lib. Okay, well this sounds great, but here's another twist. U8g2 is not dependent upon a particular microcontroller unit. So U8g2 was not written for the ESP32. I think it was probably written for the Arduinos, but it was certainly not written for the ESP32 or the ESP8266 or the Raspberry Pi or a variety of other devices. So instead, what U8g2 provides is what's known as a hardware abstraction level. And what that means is U8g2 assumes that there are functions with specific interfaces, that when those functions are called, they know how to drive your microcontroller unit. They know how to set GPIO pins to 1s and 0s. They know how to drive I2C and SPI and all the others. So in order to use U8g2 in conjunction with the ESP32, we have to provide a hardware interface layer that maps from the U8g2 technology, the library, to the underlying ESP32. And in order to make that work, we've gone ahead and provided the hardware abstraction level. So there's another set of C language APIs here, which you want to link in with your U8g2 lib. Instructions for how to build the ESP32 U8g2 lib are also provided here for the ESP32. It's very, very straightforward, just a few simple instructions. And if you're familiar with the ESP32 IDF, shouldn't pose much of a problem. Now let's look at a sample application. So here is a simple ESP32 application that's included the U8g2 libraries. The first thing we want to do when we start our application is call this ESP32 hardware abstraction layer init function. This takes as input a structure which identifies which ESP32 pins we want to use for which logical functions. So here we're using SPI, so we're using MOSI and clock and chip select, and then there's data and command and reset specifically for the device I'm going to use, which is an SSD1306. Then we are solidly into the U8g2 library APIs, and there's nothing here that you couldn't pick up from the standard U8g2 API documentation. So we tell U8g2 which kind of display we're using. We're using an SSD1306, 128 by 64. We pass in the hardware abstraction layer callback functions, which again, this is where we map between the U8g2 library functions and the ESP32 specifically, and then we make U8g2 APIs. And when I run that, we get a graphical display that looks like this. And as you can see, it's a pretty picture, but and follows these API commands that we executed here. Of course, you can change this logic to do whatever you would like, to draw whatever characters or text that you have on the screen. And of course, if you're using displays other than the SSD1306 OLED, then one would simply map that to the correct setup attribute here, and we are good to go. So again, doesn't have to be complicated. The real story here is that one can use the U8g2 library. One should map that to the ESP32 APIs. We've provided you a sample hardware abstraction layer mapping, and from there, it's up to your own imagination of what you want to draw on your screens. Alrighty guys, I appreciate your time, and I hope you've enjoyed this video. Look forward to making more in the future. Thanks now, and bye-bye.